Greetings, folks, and welcome to the Electromaker podcast. This is your roundup of all things Maker and embedded and lovely, albeit in audio format. And we are back after a short break with a fantastic show. There's so many things in this that I was really excited to talk about. Not least, the first time that a prize that we've given out has shown up as a project on the Electromaker website. Yes, the Firebeetle, which was the ESP32-based development board that we gave away a few weeks ago, has now a project attached to it. And it's a fantastic smart home gas sensing project that we'll be talking about at some length. Also looking at a synthesizer that uses an STM32 black pill, and long-time listeners to the show will know that that is something that I'm very excited about talking about in general. Any microcontrollers plus music is very much my thing. Also announcing the winner of the Zima Blade and talking about our current product of the week, which is the Microbit version 2, and a few other things, funding website things, and a fantastic new MCU. So with all of that to get through, we're going to get on with the show in just a moment. But before we do, just a quick reminder, this podcast does not have any sponsored sections or any advertisement sections, but we do have a store which you can find at electromaker.io/shop. We have a great stock of everything. We've just got a new stock of Raspberry Pi 5s in. If you've been having trouble finding one, you can get one from us, along with pretty much anything else you would need for any Maker or embedded project. All right, I think that is everything. So let us get on with this week's podcast. We're going to start this week's show with a project on the Electromaker website, but this one's actually quite special to us because this is a project from Ralph J.Y. And Ralph was the person who won the Firebeetle 2, which was a competition that we had a couple of weeks ago. It is an ESP32-based development board with a couple of nice things on it, including this display socket, which, as you can see, has been paired here with a mini touchscreen. And Ralph has made a fully self-contained battery-powered gas sensor, which has a node red front end in order to see the gas readings at any given time. And it's just a really nice thing, because one of the things I've said over and over while we've been doing these competitions is I love the fact that we get to give this hardware away to people, but what I'd love to see the most is what you do with it. And so for me, this is a very special moment. And it is a lovely project as well. So I urge you to go and read the wonderful documentation of it yourself. I don't have time to go through it in absolute detail right now, but I'll give you the cliff notes. So, as previously mentioned, ESP32-based development board, touchscreen, and a multi-channel gas sensor from Seed Studio with a Grove connector. This project also has an in-house battery because this Firebeetle 2 supports battery charging. It has a battery manager on board. And Ralph also created a nice 3D printed case for it. We'll get to the code and firmware and all that kind of stuff in a moment. Yeah, there's a 3D printed case here, and you can sort of see how this all fits together. The screen will go on top of the case here and fit in it so you can see the screen. And there's a breakout here for the Grove connector for the gas sensor, because ideally you want your gas sensor to be out in the open and pick up, well, gas. And here you're seeing the case closed. It's still on USB power as it stands right now. And this sensor is actually a temperature and humidity sensor that Ralph was using for testing. He's got experience with this particular module. It allows him to test everything else. Is the ESP32 board working the way he wants it to? Is the screen working the way he wants it to? And the hardware coding was done using the Arduino IDE. You can add this to your boards manager in order to get ESP32 devboard support. And as you can see, the Firebeetle 2 is supported here. And further down in, here, you can see all of the example code. There's a GitHub library for the multi-channel gas sensor that he used. And there's a wiki for it as well, just here. So if you're interested in finding out more, you can find those from this link. I'll link the main project in the description. And here you can see it working by itself on battery power, just a completely standalone gas sensor. And this is the hardware side of the project. And this alone would be a really fun DIY gas sensing project with some real utility. You could, for example, add a buzzer and set it up there. If there were any massive changes in any of the gas sensor readings within a very short amount of time, it would start beeping, because presumably you'd want to know about that. So on top of the hardware side of things, Ralph decided to turn it into an MQTT device on his local network using Node-RED. And Node-RED, as the name suggests, is node-based logic for taking data from one place and putting it somewhere else, including visualization on the dashboard. So you're seeing here the temperature and humidity and pressure from the initial tests that Ralph did. I don't know if I mentioned this or not. Before putting the gas sensor in, he tested it with a temperature and humidity sensor that he had previous experience with, just to test the hardware run-up. But if you look further down, you can see the Node-RED flow for the gas sensor, and here's all of the different gas sensing too. It's just really nice to see such a complete idea for a project carried out, again, by something that was one of the competition winners, because I always say how much I would love to see the things that people make with them, and here's actual evidence that one of the things that we put out there into the world has been put into someone's home project. And I really look forward to see where this goes next. I know that from reading the project, you have a little bit more tinkering you want to do with this, Ralph, and thank you so much for putting it up on the website and giving me something so wonderful to open this week's show with. Just quickly before moving on, if you do want to support us, a great way you can do that is by shopping at our store, and all of the bits from this project are available in the Electromaker store, including the Firebeetle itself. Also, if you'd like to find out more about the Firebeetle, I did talk about it a few shows ago, but there's a blog for the Firebeetle too, our product of the week that Robin does, including a video going through everything that's good about it, and of course a link to where you can get one in our shop. And I should add a link to Ralph's project to it as well, because this is a wonderful thing that you could make with it. Now, up next, we're going to be talking about a $20 synthesizer that you can build using a STM32 black pill and a very cheap I2S DAC and a few other components. It has MIDI input and it sounds absolutely wonderful, and it's called the BP Synth and it's by Synth Tech. Now, I'm very surprised I didn't talk about this when it first appeared on the internet, because I've been following Synth Tech for a while. Not only is the BP Synth one of their creations, their channel has got a huge amount of educational content on it too, as to how you can get started with digital audio, how you can start with MIDI, and a lot of things that I am very interested in. I've made no secret of the fact that in my spare time, I am very slowly working on a fully digital synthesizer, which uses, well, I haven't really settled on the hardware I'm going to use for it either so far. I've been mostly trying to learn how to make synthesizers that don't sound horrible in code, and it's a slow process for me, but Synth Tech is one of the many YouTube channels that I find very useful. The reason I'm talking about it again now is because Floyd Steinberg, another very interesting YouTube channel who covers a lot of crossover DIY and just normal kind of music tech stuff, has just put up a video about the BP Synth, which is a wonderful introduction to it and a wonderful tutorial to it as well. So before we go any further, I want to give you a couple of quick examples of the sound. One from Synth Tech, the person who created it in the first place, and one from Floyd. Now, I probably had to cut both of those down quite small for timing, and both channels make it very clear that these are just demo sounds from the board, not necessarily supposed to be fully put together tracks. But even from those alone, you can hear that this has a real depth of sound to it, and it really does bring to mind the kind of analog sounding things that you would expect from an analog sounding synthesizer. The DSP side of it has been wonderfully put together, and Synthtech has done a wonderful job of that. What Floyd brings to the table, as he always does, is a very clear and easy to follow video for anyone who just wants to get this thing up and running, who maybe is at the more of the start of their journey, whereas Synthtech is someone who has done the hardware side of things, done the software side of things, and is deeply in the weeds and knows how this all works. This is a video for someone who just wants to build their own synthesizer and follow a nice step-by-step guide. And Floyd tells you absolutely everything you need to know, including how to solder it, tips and tricks for getting it right, and doesn't go into the depths of exactly what every single thing does, which for some people might be terrible. You might want to hear every single groove